This lesson is about the best fit algorithm, finding what's the maximum number of small objects, like a box possibly, that can fit into a larger container. And we'll look at that both in 2 dimensions and 3 dimensions. Okay, so we have a small red rectangle, and look at a large black rectangle, and we're just trying to see how many of the little red ones go into the big black one. There's a couple of ways of doing this when it's in 2 dimensions. This it isn't too difficult, but essentially what we're trying to do is we're just going to we'll do it visually to start with, and we'll put a little red box into the black box. But we could have it in 2 orientations. Obviously, we can have it as it's sitting at the moment, like as if the red box is vertical, but we could also turn the red box on its side and see how many we could get in that way. Okay, so let's try it. We'll have to try it both ways to see which one gives you the highest number, and that would be the maximum. Now, it is really important that you don't calculate the area or the volume if it's in 3 dimensions. That's one of the most common mistakes with these questions, where you find the area of the black triangle, find the area of the red rectangles, and divide them, and that number gives you how many will go in. That's true, it does, but it doesn't take into account the kind of wasted space, and you could get the wrong answer basis. So don't do that, because it's not how we want to do it, and if you do it, you get no marks in the question. Okay, so this is the way to do it. So here we go, we've got 2 rectangles, 14 by 8 is the wee one, and 45 by 54 is the big one. They're all centimetres. Okay, so we look at it vertically, so as it's sitting, as it is at the moment, and we're going to try and stick these into the big black box. Okay, so there we go. Let's start off at a corner. So there's 1, 2, 3, 4, 5, and 6. So we can get 6 along the way. So that's 6 in a row. So we really need to know how many rows we're going to get in, and then we can just add them up and see how many we've got. So let's see how many we're going to go high. So let's just go. Obviously get there's another 6 along there on top of that, and we can just squeeze in another 6 on top of that. So we can add up 6, 12, 18. So we get 18 boxes in total can fit in. Now that's great if you can draw it and draw accurately. That's all fine. I'm on the computer, so that makes it nice and easy. If you were doing it on a bit of paper, that makes it a bit trickier. So it's easier if we can do it mathematically, and you get exact, because there's obviously a bit of error on what I've just done as well, whether things are overlapping or not, there's a wee gap, whatever. So you might not get it absolutely spot on. But if we do it mathematically, doing some calculations, then we'll get the exactly correct answer. Right. But and what's important here is that we look at the dimensions on the 2 rectangles. So in this case, we've got a 54 going along the bottom of the black triangle and an 8 going along the bottom of the red triangle. So those 2 dimensions are going to correspond with each other. So we need to see how many 8s will go into the 54. And same with the height of the 2 boxes. We've got 45 high with the black box and 14 high with the red box. So we want to see how many of the 14s go into 45. That's the 2 things we're going to do. So we're doing a bit of division basically. Okay, so for the length, we've got 44 divided by 8, and that comes out to 6.75. Now, we don't care about the 0.75, so we're going to discard that completely and just have the whole number. So we get 6 boxes along the length of it. Now, we know that already from our drawing. So that works, so we're happy so far. And let's look at the, I've said breadth, height, call it whatever you like. Doesn't really matter, it's the dimensions corresponding that matters. So we've got 45 divided by 14, and that comes out to 3.21. So that means it's 3 boxes high. So we've got 6 by 3. We just need to multiply them together. So 6 times 3 is 18. So you're dividing to start with, and then you multiply your answers together to get your answer, your final answer. Okay, your total. Okay. Here's one for you to try. Oh no, I haven't done the horizontal yet. What are you talking about? Right. Okay. Sorry. So need to. So that's it vertically. That might be the most, but we need to check to see if doing it the other alignment gives it the most. So we're going to turn the red box on its side. Keep the black box the same. The big one just the same. It doesn't change at all. but now obviously the 14 corresponds with the 54 and 8 corresponds with the 45. It's the other way around. But let's do it visually as well. So there's 1, 2, 3. There's not enough space here to get another one in. So we've only got 3 in a row. How many rows have we got? 2, 3 rows, 4 rows, and we can just squeeze in a 5th row. So from our visual, we are getting 15 of the wee red boxes in there. Let's see what our calculations give us. So we said the 14 is now with the 54, so 54 divided by 14 gives me 3.86, so that's 3 boxes. We're happy with that. And 45 divided by 8 gives me 5.63, which is 5 boxes. So we're happy with that as well. So we multiply the 3 by the 5 to get 15 boxes. We're spot on. So if we do it horizontally, we only get 15 boxes. If we do it vertically, we get 18 boxes. So which one, what's the maximum number we can stick in? The maximum is 18. So you need to do it both alignments and see which one's the biggest number. And just write that down, the maximum number of boxes is 18, or whatever it is. Yep. Okay, so here's one for you guys to try. Same idea, we've got a big rectangle and a small rectangle. Just seeing how many of each in each alignment fits in, and then see which one's the maximum. Okay, pause it here, give it a try. Okay, so vertically, we'd be doing 204 divided by 24, which is 9.71, so that's 9 boxes in a row. And then the breadth is 125 divided by 31, which is 4.03, so that's 4 boxes high. Multiply those together and you get 36 boxes. So 36 boxes vertically, if it's in alignment it is, as shown in the question, we get 36 boxes. So let's flip the wee box on its side, so horizontally, and now we're doing 204 divided by 31, which gives me 6.58, so that's 6 boxes. And 125 divided by 24 is 5.21, so that's 5 boxes. And multiply those together and we get 30 boxes. So again, it's the same answer as the first one in terms of its alignment, it's vertical, but this time it's 36 boxes, the maximum. Well done if you managed to get that, that's good. So the thing to remember here, all we're doing initially, we're dividing the corresponding dimensions of the objects, and then whatever your answer is, you round down to the whole number and then multiply them together. That's your kind of strategy. Now that's it in 2 dimensions, exactly the same in 3 dimensions, not any different. You just do exactly the same thing. The only thing that's different is you've got 3 dimensions to go by, but we use exactly the same strategy. So here's my large container, my large box. It's got 3 dimensions, x, y and z. So what's difficult about 3 dimensions, you just get more possible alignments. So there's your wee box, it could be like that, it's A, B, C, so the A is the same as the X, correspond to the X, B's correspond to the Y, C's correspond to the Z. But it could also be aligned like that. So the B and the A are switched around, so the B's now correspond to the X, the A to the Y, the C still to the Z. So it's 2 times. How many different alignments can we get? Let's see. Right, so we could knock it on its side, so now the C is corresponding to the Y, the A is corresponding to the X, and the B is corresponding to the Z. Okay. We could again flip the A and the B round, so the C is still corresponding to the Y, the B is to the X this time, the A is to the Z. There's the C is now corresponding to the X, B to the Y, A to the Z, and C to the X, A to the Y, and the B to the Z. So there's 6 different alignments that you can have with a 3-dimensional object. Now in general, in past paper questions, you'll see that we often minimize how many different alignments we can get by saying that the box has to be this way up. You get that in container boxes all the time because the object is fragile or whatever, and it should be a certain way up so it doesn't get damaged, and it'll mark that on the box. So that is often the case in past paper questions. So you only have to do 2 of the possible 6 alignments, which makes life a bit easier. It's just repetition if you've got to do all 6. It's not really any, you're not doing any more difficult calculations or anything like that. You're just doing the same thing again and again and again and again. Okay, so let's see an example of this. Okay, so there's my big container is 2.3 by 3.4 by 4.2, and I've got a wee box which is 50 centimetres, 75 centimetres by 92 centimetres. Now you'll notice there's centimetres and metres there. It's really important that you get them in the same unit. So either change the meters into centimetres or the centimetres into metres. It doesn't really matter which way you do it, as long as they're both sets of dimensions on the same units, that's fine. So we've only got two possible alignments because it's this way up, so it's, if looking back to the previous page, it's just the first two alignments. So you've got that, so the 50 corresponds to the 2.3, 75 corresponds to 3.4, and the 92 corresponds to 4.2. The 92 will have to correspond with the 4.2, no matter what, because otherwise you'd be turning the box on its side. So the other alignment is that. So the 75 is corresponding to 2.3 now, and the 50 is corresponding to 3.4. As I said, you need to get it into the same units. Right. Okay, here's one for you to try. Just pause the video here and see how many of those wee boxes can go into that big box. So it has to be that way up as well, just like the example. So the 45 centimetres has to correspond to the 5.6 metres. So you're only going to do two alignments and see how that goes. Pause it here and see what your maximum number is. Okay, so we do the 2.7 divided by the 0.4, so we get 6.75, so that's 6 boxes. On the breadth, we get 4.2 divided by 0.6, that gives us 7 boxes. And the height, 5.6 divided by 0.45, which gives us 12 boxes. Multiply those three together, you get 504 boxes. Let's do other orientation, so this time the 60s go with the 2.7. So 2.7 divided by 0.6 is 4 boxes. The 4.2 divided by 0.4 is 10 boxes, and we've still got the 12 boxes going up the height. So 4 times 10 times 12 is 480. So 504 is the maximum number of boxes we can fit in this way up. So well done if you managed to get that. Good job. So now there's just the next